Okay, everyone. Today we will move to chapter number 10, regression and correlation. And next week we will discuss something about chi-square and ANOVA test. Then today is May 26th, and next week, June 2nd, then is our final exam. And on the last week, week 18, I will explain how to solve those problems. Yes, the same rules. You are allowed to use any kind of materials, any kind of including electronic devices, including paper or textbook, anything you can use, but no discussion during the exam. No discussion. I mean online discussion or on-site discussion. Is it okay for everyone? And sure, I hope you can enjoy the test, the exam. Okay, before I start, today we will discuss about the regression and correlation. Before I start, just a reminder. Sorry. Okay. As I mentioned, I try to encourage everyone to digitize your notes. How to do that? I think previous semester, many students in this classroom already did the work, so they are familiar with this. And please report class assignment or notes on public website or homepage. And sure, to the public website or homepage, it means your content can be searched. Your contents are searchable. And this moment, I did not prohibit you. I just encourage you, besides the Instagram, Facebook, Twitter X, something like this, you can place your information on the public website. What does it mean, public website? As long as a reader, he or she has a device, has a network, he or she can read the content from you. But if you publish your class assignment on Facebook, on Twitter X, on Instagram, or something like this, they need to register an account in order to read your content. That is not good. Why? Because only registered member can access the website. Again, only registered reader can access the website, and it's not good enough. Thus, I encourage you to publish your content in the website. Okay, and here I have a link. I encourage you to report your website. Let's take a look at this here. And sorry. Okay, I forgot to mention that when you read www.blogger.com and something like this, it's not a public website. Please modify it. And this one looks okay. And like this one. Oh, looks great. But just a reminder, my original data from Google Sheet, the data from textbook here. Yeah, you need to cite the source of your information. Otherwise, it becomes plagiarism. Plagiarism is steal the ideas or steal information from somewhere. That is not good. Okay, that is not good. So you need to cite the source of your information. Okay, this one my original data from here. Okay, is okay. And next, yeah, and I also encourage you to use your real name on the website. Okay, why? Because your name is your brand, your company name, like your company name. You need to promote yourself. You need to promote yourself. Like me, I have my way to promote myself on the internet. For example, I recorded many videos about teaching, and another YouTube channel, I released many daily life. For example, I taught my kid how to cook, how to repair some electronic devices at home. Okay, and this one, yep, looks okay. And this one, okay. And sure, and I also encourage you to have your name on the website, on the website title. Then I can recognize you. And see, this one, learning about food and nutrition. I believe that this student used the original website from previous semester, and this time, maybe you can have your name. For example, John's learning website, John's opinions on learning, or John's assignment on classroom, something like this. And if you use this name, is previous semester, and this date is the new date. Hey, it looks okay. And how about the next one? Shallow de Aziz Sira. Okay. Yeah. Sure. If you took a picture and upload the picture, it's also okay. It's also okay. Okay. Again, I encourage you, if you have your own website, this one is optional. It's not a requirement. Optional. Student who to pursue higher scores, the other 20%, you can write your notes like this one. And you can check the students' notes from next semester. You can click here. And again, let me share this information. Oh, okay, I'm done. Okay, any question? Okay, just a reminder again. Next week, we will move to chapter 11. Chapter 11, that's chi-square. And next week, the June 9th, is the final exam. And please remind me, I will give you some old exams and videos. You can review the content from the previous year. And on the last week, okay, I will explain the exam questions. Okay, then, okay, any question? No? Okay, no more question. I will move. Yeah, again, I encourage you to report your website, and the website can start from your name. For example, I got your student number from this website, but I don't know whether this one is your website. Please place your name, at least your first name. Sure, I encourage you to type your full name on the website as the website title. For example, John Churi's learning website, John Churi's opinions, John Churi's personal homepage, something like this. I encourage you to do that, like me. Is it okay? Okay, let's move to the regression. Okay, regression and correlation. The previous chapter looked at comparing populations to see if there is a difference between those two samples or those two populations. They involve the two random variables. They are similar measures. This chapter will look at two random variables that are not similar measures and see if there is a relationship between those two variables. Here again, if there is a relationship between two variables, for example, we want to know if a person's body weight is it related to the food he or she consumes, and we can check because how much food for one person's meal, that is one variable, and the body weight is another. Before we may think absolutely they are correlated. Before we say absolutely, we need some scientific evidence to show, okay, after the calculation, after the analysis, we can say a person with higher body weight will eat more food, like this one. Okay, to do this, you look at regression, which finds the linear relationship, and correlation, which measures the strength of a linear relationship. Okay, note, there are many other types of relationships besides linear. They can be found for the data. This book will only explore linear, but realize that there are other relationships can be used for describing data. That's one way. For example, I am a food microbiologist, and we did something about the viable cell count and optical density. The correlation is very significant, especially we take the logarithm, the value of the viable cell count, and we did a regression. With the optical density with a machine. Okay, let's move to the regression. Regression. When comparing two different variables, two questions come to mind. Is there a relationship between two variables? And how strong is the relationship? These questions can be answered by using regression and correlation. Regression answers whether there is a relationship. Again, this book will explore the linear regression only. Sure, there are some, for example, we can take a the log value, then do the regression. You can take some different transformation. It depends on the data. And correlation answers how strong the linear relationship is to introduce both of these concepts. It is easier to look at a set of data. Okay, example 10.1.1. If there is a relationship, is there a relationship between alcohol content and the number of calories in a 12-ounce beer? Yeah, it's a good question. Good question. Again, is there a relationship between the alcohol content and the number of calories in 12-ounce beer? To determine if there is one random sample was taken from beer's alcohol content and calories in beer. Here is the information source. Okay. And the data is in example 10.1.1. And here, brand name. The first one, Big Skyscape Gold Palm Alley. The alcohol content, 4.7%. Calories in 12 ounce in a can, that is 163. And the second one, Sierra Nevada Harvest Ale. Ale or lager is different kind of fermentation skill, and it makes different type of beer. Okay. And the alcohol content is 6.1. The calories in a beer can, that is 215. Okay. Then this one, roughly the alcohol content is 0.4, and the calories is 70. Okay, after those information, solution to add in figuring out if there is a relationship, to help to draw a scatter plot of data. Again, scatter plot, later I will demonstrate how to do this. It is helpful to state the random variable, and since in an algebra class the variables are represented as x and y, these labels will be used here. It helps to state which variable is x, which is y. Okay, the random variable x, that is alcohol content in the beer. Random variable y, calories in a 12-ounce beer. And see, we can see the trend. You can see the trend. Seems there is a line goes across those data. Look like this. Okay. And this scatter plot looks fairly linear. However, notice that there is one beer in the list which is actually considered non-alcoholic beverage, like this one. We think is non-alcoholic beverage, like this one. This point is far away from the group. The value is probably an outlier. Again, please memorize this term, outlier. Okay. Since it is a non-alcoholic beer, the rest of analysis will not include this or those beer. Okay. You cannot just remove the data point but in this case, it makes more sense too, since all the other beers have fairly large alcohol content. And to find the equation for the linear relationship, the process of the regression is used to find in the line the best fit of the data. The best fit of the data, sometimes called the best fitting line. Best fitting line. The process is to draw the line through the data. Okay, like this one, don't worry. This one, ignore the first point. This one, I will tell you that as long as you know how to run the calculation, this part is easy. But the principles are really hard. Very hard. Okay. And to find the regression equation, as known as the best fitting line or least square line. For example, when I was a master student, when I was a PhD student, we need to use the best fitting line to calculate, to predict some detection. And here, give a collection pair the same data. The regression equation is y hat equals a plus bx, where the slope b is like this one, and the y-intercept is a. A equals y bar minus b times x bar. Okay, definition. The residual are the difference between actual value and the estimated values, like this one. Residual, that's definition. And SS stands for sum of squares. So you are summing up squares with the subscript xy. Xy is here. Subscript, the location is lower, and the font type size is a little bit smaller. And sum of square xy, sum of square x, sum of square y, do like this one. Actually, this part, maybe you don't need to calculate, because nowadays the software can do it very well. Okay. I think we can return to this one. Now, please. Oh, no, maybe we can move forward. Okay. Then later we can come back. Definition 10.1.3. The population equation look like this one. Y equals beta 0 plus beta 1x. Beta 0 is the slope. Beta 1 is y minus interception. Okay. Y hat is used to predict y. Yep, we are the purpose to predict this. And example 10.1.2, find the equation of the regression line. As long as you know how to click Google Office, after you become familiar with operating the software, you can get the answer in a few minutes. Believe me. Okay. Example 10.1.2. A. Is there a positive relationship? Sorry, I will postpone the break time. Between the alcohol content and the number of calories in a 12-ounce beer. To determine if there is a positive linear relationship, a random sample was taken from beer's alcohol content and check the calories for each beer. And B, use the regression equation to find the number of calories when the alcohol content is 6.5%. Use the regression content to find the number of calories when the alcohol content is 2.00%. D, find the residual and then plot the residuals versus the x values. like this one, like this one. Okay, the answer is y hat equals 25.0 plus 26.3x, like this one, like this one. Now, please do this in class assignment. Let me show you how to do this. Okay, please follow my steps here. Follow my steps here. First one, please go to the Google Drive and create a new file, Google Sheet. Okay. Okay, then select the suitable range and copy and move it here. Okay, is it okay? Okay, we will focus on these two. Okay, like this one. And next, we need to select the range here and insert chart. And now we don't need a column chart. We need an XY scatter. Scatter like this one. Click. Okay, before I move forward, let's check the diagram. See, very similar, right? The diagram here, very similar. And here is outlier. In the textbook, it explains this is a non-alcoholic beverage, non-alcoholic beer, like this one. Is it okay? Okay. How about use 3 minutes to finish this one, and please write as your note. Okay, again, the key point is select the range and select scatter chart, insert chart, and select, because the default is column chart. We don't need the column chart or the pie chart this moment. We need the x scattering chart like this one. Is it okay? Okay. Questions? Questions? Okay, if no more question, have 10-minute break, then see you later.